Hi, ladies and gentlemen, this is Ms. Skokin. We are in Chapter 1, Foundations for Geometry. We're going to be learning a lot of new vocabulary, and we're going to be very picky about what the geometric figures and their names and the notation are. So let's get started. Section 1-1, Understanding Points, Lines, and Planes. Our objectives are to identify, name, and draw points, lines, segments, rays, and planes, and apply basic facts about points, lines, and planes. We've got a lot of new vocabulary: undefined term, point, line, plane, collinear, coplanar, segment, endpoint, ray, opposite rays, postulate, and intersect. So let's take a look at what the basic elements of geometry are. As always, I want you to get started with a warm-up. So graph the inequalities listed in questions 1, 2, and 3, and then turn the video back on when you're ready to check your answers. For question number 1, we have a very simple inequality. It has the x is greater than or equal to, so we have a closed dot on the 3, and the variable's on the left, so we know that inequality symbol is pointing to the right-hand side. So all values of x that are greater than or equal to 3. For number 2, we have an inequality with x in the middle, so you may remember from Algebra 1 that that is an and compound inequality. So and implies the intersection of two areas, so it's going to be the intersection of all the values of x that are greater than or equal to 2, along with they also have to be values of x that are less than or equal to 6. So it's the overlap of those two areas, which ends up being x in the middle, just like in the inequality. In question number 3, inequality number 3, we have another compound inequality, but this time the two inequalities are joined by the word or. We know that that means union, and that means we're going to include both areas. We have x is less than 1, all values of x that are less than 1, so we have an open circle, and the arrow goes to the left, or all values of x that are greater than 0, so again an open circle, this time all the values that are to the right or greater than 0. That ends up covering the entire number line, so our answer with the number line in blue is our final answer. And if we were to write that in some type of set builder notation or a final answer, we would say all real numbers, because all numbers on the number line will satisfy that compound inequality. There are many important mathematicians in history, and some went from philosophy to different sciences to different types of mathematics. Euclid is known as the father of geometry. He wrote a book called Elements, and it is still used into the 20th century to teach geometry. We're going to learn some of the things that Euclid taught and how he taught that we still use today, because they're still valid. So let's take a look at some of those new undefined terms that were defined by Euclid. Euclid called the most basic figures in geometry undefined terms because they can't be defined by any other figures. You can't get more basic than an undefined term. So the first one that we're going to come across is a point. A point is a location in space. It has no size, it has no dimensions, and we represent it with a dot when we're drawing it. When we give the point a name, it's always going to be a capital letter. So we might call it point A, point B, point C, or we might call it, as in this example, point P. A line is a straight path that goes forever and ever and ever in both directions. It has no thickness, so it has no width dimension, and it really has no length because it goes on forever. The way that we indicate a line is by naming it with a lowercase letter such as L, or we can also name it by any 2 points on the line. So notice the notation. The line in our diagram can be either known as line XY, and it has the symbol of a line on top of the 2 points, point names, or it can also be known as line YX. Any 2 points that are on that line can name the line, and it must have the line symbol above the 2 point names. A plane is a flat surface that has no thickness, goes on and on and on forever. We can think of it as a sheet of paper, but that goes on forever in every direction. And the floor, for example, if we go outside and we look at the ground goes on forever and ever and ever in every direction. That would be an example of a plane. Now we know that I'm not saying that the earth is round, don't get me wrong. I know that it is not flat, but it's just one image that we can use to think of a plane. The way that we indicate a plane is either a fancy cursive letter like you see here with the letter R, or any three non-collinear points that are on the plane. So for example, points A, B, and C are kind of in the form of a triangle, not all along the same line. So we can use those to indicate the plane ABC. If I had another point, let's say point D, that would be collinear, I would not be able to use A, B, and D to name plane R. It just wouldn't work because they're collinear, so they name a line, they cannot name a plane. So I'm going to erase that because that's not what we want to use. I used a new term a few minutes ago that is collinear. Points that lie on the same line we call collinear. So in our diagram, we have points K, L, and M that all lie along the same line. Those are said to be collinear. We know points K, L, and N are non-collinear, meaning they do not lie along the same line. Now, in the diagram of the planes, we have points, let's see here, A, B, C, and D. A, B, C, and D are all on the blue plane. They lie on plane N. Points A, B, C, and E are not coplanar because we can see point A is on the blue plane, but point E is on the orange plane, so they're not on the same plane. These two planes appear to be perpendicular. We don't know for sure if they are or not, but we can see that they intersect, and they intersect on line BD or line BC, depending on what you want to call it. But point E lies on plane F, and point A lies on point N. We're going to continue to try to use two-dimensional representations for three-dimensional space, but we will get better at it. In example 1, we want to name 4 coplanar points, and we are going to use proper notation. Points A, B, C, D all lie along that purple plane that I've highlighted. Remember that we have to use capital letters to indicate points. Now let's take a look at 3 lines using proper notation. There is a line that goes from point A through point E. I'm highlighting it in green, and we're going to call that line AE because those are the 2 points that it goes through. Remember that we need to have the little line symbol over the top of it. We see another line that goes through points B and E, and we are going to name that line BE. We could have also called it line EB. Would work out exactly the same. We were asked for 3 lines, so we need one more, and we have a third line that goes through points E and C, so we can call that one line CE. Remember, we can also call it line EC. The order doesn't matter when it comes to lines, but it does matter when it comes to rays, so just keep that in the back of your mind. Speaking of rays, let's take a look at what segments and rays mean. Where lines go on forever, segments don't. They actually have a starting point and an ending point, and we call them both endpoints. So when we're talking about segment AB, or we could also call it segment BA, it's going to have 2 points, points A and B, and the segment is all the points between and including points A and B. It stops, it ends. It's not like a line that goes on forever. Now, an endpoint is a point at one end of a segment or at the starting point of a ray. We always designate it the way we designate all points, such as C or D on our segment CD. Now let's talk about a ray. A ray is a part of a line. It starts at an endpoint and it goes forever in the other direction, opposite the endpoint. So if we're talking about ray RS, we have to write it with R as the endpoint, and it goes through point S. So here we have two different ways that we can have segment RS. It starts at endpoint R and goes through point S and then goes on forever. We designate the forever with an arrow. We could also say it starts at point R and goes through point S and goes on forever. It doesn't matter what the direction is that it goes on, but we always have to name, in the name of the ray, the endpoint first. Opposite rays are two rays that have a common endpoint. Now, that means that there is one point that starts out both rays. So we have ray EF going in that direction. We have ray EG going in that direction. They must form a line in order to be opposite rays. So we could say that these two opposite rays form line FG, and that would be true. But it comes from ray EF and ray EG, opposite rays. In example number 2, we want to draw and label in part A a segment with endpoints M and N. So we have point M, we have point N, and the segment between them forms segment MN. For part B, we want to draw and label opposite rays with a common endpoint T. So I'm going to draw the T first. There's point T. I'm going to have two rays. Remember that they have to form a line. And so I'm going to have ray, we'll call this point S and this point U. So I'm going to have ray TS and ray TU. They have to have a common endpoint, so that first point in the name has to be the same. Okay, time to talk about postulates. A postulate or axiom is a statement that is accepted as true without us needing to prove it. We're going to be using a lot of postulates this year about different geometric figures that describe geometric properties and geometric relationships. So let's take a look at the first three that we have in our box about points, lines, and planes. First of all, through any 2 points, there is exactly one line, okay? We've always known for a while that it takes 2 points to define a line. Now we have a postulate that also says so. The next one says, through any 3 non-collinear points, there is exactly one plane containing them. We talked about that a few minutes ago also. And the third one, if 2 points lie on a plane, then the line containing those points lies on the plane. And that makes sense. It's kind of like where that line cannot be floating up in space if the points that the line goes through are sitting on the plane. All right, let's take a look at example 3. We want to identify points and lines in a plane. We want to name a line that passes through 2 points. We can see that we've got line XY. We could have called it YX. Also, remember that we have to have that line symbol above it for proper notation and capital letters. In Algebra 1, we learned all about intersection, and we know that that means that 2 lines, in our case it could also be segments or rays, go through the same point. They intersect. So an intersection is a set of all points that 2 or more figures have in common. And we have 2 new postulates. The first one says if 2 lines intersect, then they intersect at exactly 1 point. So if 2 lines intersect, that's at exactly 1 point. And if 2 planes intersect, they intersect in exactly 1 line. All right, in example 4 in part A, it says sketch 2 lines intersecting in exactly 1 point. And that is definitely not difficult for us to do. I'm going to call it line L, and then I'm going to also have another one we'll call line M, and they intersect in exactly 1 point. Part B says sketch a figure that shows a line that lies in a plane. We're going to try to do a 3-dimensional plane that appears to go off in every direction. And on that plane, we are going to draw a line laying on it. Okay, sketch a figure that shows a line that lies in a plane, and we have done that. It does not go through the plane. So part C says sketch a figure that shows a line going through a plane. So again, we need a plane, but this time our line is going to kind of pierce through that plane. Imagine taking a toothpick and piercing a piece of paper. So I'm going to draw it going kind of upwards, and then this is where it goes through the plane. So I'm going to have dotted lines to designate where we can't see it because it's kind of behind the plane, and then this is underneath the plane coming through the side that we can see. So that's a figure showing a line going through a plane. That's it for our notes. We're going to have some practice problems to work on in class, so I will see you in class. Just a reminder that if you have any questions about anything that we've discussed, please jot it down in your notes and we will go over them at the beginning of class. See you soon.